So 2.5 is on transformations of functions. So this is straight out of your book. It's just a, I guess maybe it's not out of your book. I thought this was out of your book. Maybe it's something else I found on the internet. I don't know. It's in your book also, though. Just a brief description of the transformations that you've learned. So remember that if we're adding or subtracting to the back of a function, it's a vertical shift. Positive is up, negative is down. If we're adding or subtracting inside the function, it's a horizontal shift, but it's opposite. So plus is to the left and minus is to the right. Multiplying by a negative on the outside reflects you over the x-axis because it changes the sign of your y. If it's a negative on the inside, it changes the sign of your x, so it will reflect over the y. If we multiply by something bigger than 1 on the outside, we stretch vertically. If we multiply on the outside by something between 0 and 1, it's a vertical shrink. And then if we multiply on the inside, it's horizontal, stretch or shrink. And again, it's opposite. So bigger than 1 is going to shrink. If it's between 0 and 1, it's going to stretch. All right, so if I am asking you to take this random function and do f of x plus 1. So I want you to take all of these points and go up 1. So the point that was at negative 4, 0 is now going to be at negative 4, 1. The point that was at 2, negative 2 is now going to be at 2, negative 1. 0, 0 is now at 0, 1. 2, 2 is now at 2, 3. And 4, 0 is now at 4, 1. And then you draw the exact same picture. Or you try. Alright, so that was number 1. Alright, number 2. I'm going to do 2 or 3 of them, and then I'm going to erase everything so that it's not too jumbled. Alright, so number 2. Minus 2 on the inside means everybody goes to the right. So negative 4, 0 slides over to negative 2, 0. 2, negative 2 slides over to 0, negative 2. 0, 0 slides over to 2, 0. 2, 2 slides over to 4, 2. And 4, 0 slides over to 6, 0. So again, exact same picture, just slid to the right. Alright, so next we're going to go to the left 1 and down 2. So negative 4, 0, left 1, down 2. We have a 2, negative 2, so left 1 and down 2. 0, 0, left 1, down 2. We are at 2, 2, left 1, down 2. And 4, 0, left 1, down 2. Alright, so if you are lost, I am taking the points from this picture and making these changes. Alright, so I would say that you should probably pause and try 4 and 5, and then we'll do those and talk about 6 through 10. Alright, so 4 is going to go down 1. This one tells us to go down 1. So that point at 4, 0, and then the one was at 2, negative 2, down 1, 0, 0, down 1, 2, 2 is down 1, 4, 0, down 1, and you go this side. Alright, and then number 5, and then we will definitely try to erase and not be so jumpy. Alright, 5, negative on the outside is going to change the y. It's going to reflect over the x-axis. I'm trying to show you with my hand so if you can see it, sorry. So if I take negative 4, 0, that's on the x-axis, so it doesn't move. 2, negative 2 becomes 2, positive 2. 0, 0 is on the x, so it doesn't move. 2, 2 reflects over to negative 2. And again, 4, 0 isn't going to move. So we have the exact same picture from over here. We just reflected over the x. Alright, all of those are going to go away. And we're going to work on the other ones. Alright, so number 6. You have a negative multiplied on the inside. So that's going to change your y's. It's going to reflect this over the, I just said the wrong thing. It's going to change your x's and reflect over the y-axis. Sorry. But it's going to look like it just, for this particular picture, just like that last one that we did, because this one is so symmetrical. All right, so negative 4, 0 reflects over to 4, 0. 2, negative 2 reflects over to, that's negative 2, sorry. It reflects 2, negative 2. 0, 0 doesn't change because it's on the y-axis. All right, this point that was at 2, 2 reflects over to negative 2, 2. And the point that was at 4, 0 reflects over to negative 4, 0. All right, so if I times 2, these are the ones that give people the most trouble. If I times 2 on the outside, it's going to affect my y values. So negative 4, 0 is going to become negative 4, 0 because 0 times 2 is still 0. Negative 2, negative 2 is going to become negative 2, negative 4 because negative 2 times 2 is negative 4. 0, 0 doesn't change again because 0 times 2 is 0. 2, 2 becomes 2, 4 because 2 times 2 is 4. And 4, 0 stays because 0 times 2 is still 0. So it has stretched vertically, it's taller. I'm already used purple. Let's try whatever. I think I just picked orange. All right, times 3 on the inside. If it's inside the function, it does the opposite of what it says to the x's. So it says times 3. So we're going to divide by 3 to our x's. So y say that x is divided by 3. So if I take negative 4 divided by 3, I get negative 4 thirds or negative 1 1/3. So we slide him in to there. So negative 4, 0 slides all the way into negative 4 thirds. All right. Negative 2 divided by 3 is negative 2 thirds. So he slides all the way into here. 0, 0 is going to stay. And we have positive 2, 2. So that x2 is going to squish into 2 thirds because 2 divided by 3 is 2 thirds. And then 4, 0, we're going to squish into 1 1/3. So by timesing 3 on the inside, we are squishing or shrinking our graph by 1/3. If you could see my hands on the screen, it would be helpful, but I'm sorry we can't. All right. So next we have 2 things. We're going to reflect over the x, and we're going to double our x's. All right, so our y's are going to change sign, and our x's are going to double, because half of x, the opposite of that would be 2 times x. All right, so change the sign of the y, double the x. So negative 4, 0 becomes negative 8, 0. To negative 2, we double the x, so that'd be negative 4, and change the sign of the y, so positive 2. 0, 0, changing the sign and doubling doesn't change that. To negative 2, we're going to double the x and change the sign of the y. Oh, that was positive 2, 2. My fault. So sorry. Positive 2, 2. So double and change the sign and puts it down here. And then 4, 0 double, so it's way out here. All right, so timesing by a half actually made it fatter. It stretched it horizontally. All right, so pause and try number 10. Okay, so we are going to double our y's and add 3 to our x's. So negative 4 plus 3 is negative 1, and you can't double 0. And then let's see, for negative 2, 2, we are going to add 3, so that would be at 1, and then double negative 2, negative 4, so 1, negative 4. 0, 0, we add 3, but you can't double 0, so it's there. At 2, 2, add 3 moves us to 5, and double takes us up to 4. And then for 0, we're going to add 3, which takes us to 7. Yeah, it felt wrong, but it's good. So we have slid over to the right 3 and we stretched our picture. All right, so our goal with this lesson is to be able to do this with our parent function. So the next thing we have is remembering your parent functions. All right, so a constant function, the equation for that is going to be y equals some number. I'm just picking 2. So we would have a horizontal line is what a constant function looks like. So that domain is negative infinity to infinity. That range is negative infinity to infinity. That is never increasing or decreasing. And it would be considered an even function because it has y-axis symmetry. All right, identity or linear function, y equals x. To keep this video from being too long, I'm going to go fast through these, so at any time you need to pause, just pause. It's important that you know specific points for all of these, so I'm going to put a couple of specifics on here, so make sure you know where I'm putting those. So the one y equals x is going to just be the line that goes through the point 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1. All right, domain is negative infinity to infinity. Range is negative infinity to infinity. This one is always increasing. It is never decreasing. And it is an odd function. All right, absolute value is y equals absolute value of x. Absolute value makes the v. So it takes the line y equals x and all of these negative points flip and become positive. So you have points at 0, 0, 1, 1, 2, 2, 3, 3, yada, yada, yada. But you also have points at negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Pretend like I don't see that dot. Make yours better than mine. All right, domain is all real numbers. The range is 0 to infinity. It is increasing from 0 to infinity, and it is decreasing from negative infinity to 0, and it is even. All right, quadratic. Y equals x squared, so you got a point at 0, 0, 1, 1, 2, 4, negative 1, negative 1. That was a positive one, sorry, negative 1, positive 1. I think I did that with absolute value too, sorry, y'all. Negative 2, 4. Make sure that y'all have these videos. I'm here on Sunday trying to get all of them done. So I'm trying to be quick but thorough. So make sure if you have questions, oh my goodness. Make sure if you have questions, you email them to me. All right. So, yeah, I'm struggling hard to draw on this board. Like my pen will not calibrate. I've tried several times and it doesn't fit. Okay. So domain, it goes on forever left to right, so negative infinity to infinity. Range, it starts at 0 and goes up forever, so 0 to infinity. The bracket is because there's a point there. Increasing from 0 to infinity. Remember that 0 is an x. And it's decreasing from negative infinity to 0. And it is going to have y-axis symmetry. Everybody on this side has a friend on this side, which makes it an even function. All right, square root function. You're going to pick points that are easy. So if I plug in a 1, I get a 1. The next thing I can plug in and get a pretty answer is plug in a 4, get a 2. Then I plug in a 9, get a 3. So these 3 points are all you really need. And you just know that it's going to make, one more try. If it doesn't go, it doesn't go. There we go. It's going to make something that looks like that. All right, so this has a domain of 0 to infinity, a range of 0 to infinity. It is increasing from 0 to infinity. It does not decrease, and it's not even odd. it is neither, because these points are all in the same quadrant. Odd would have to have people down here, even would have to have something over here, and we don't have that. Alright, cubic, y equals x to the third. So 0, 0, 1, 1, -1, -1. And what I need you to remember, beyond that it's like 2, 8. So I need you to know these 3 points and that it's going to go up really fast. And down really fast. Pretend like I went through that point. Alright, domain. All real numbers. Range is all real numbers. And this function is increasing. Quickly, slowly, quickly, but the entire time it is increasing. And it is odd because everybody over here has a friend down here. It has origin symmetry. Alright, a cube root function. Cube root is going to have the same points to start with, these 3 basic points, as that cubic. But you've got to come all the way out to 8 before you get another pretty point of 3. So instead of going up, it's going to level off. So it's going to curve like this and curve like this. So domain is negative infinity to infinity. Range is negative infinity to infinity. It is always increasing, like real slow and then real fast and then real slow. It never decreases and it is odd. Okay, those are the only ones that this book wants you to make sure that you know. We have other functions that you've learned in the past, but that's all this book wants you to know because we haven't done the chapter on exponentials and logs and things like that. All right, so now they're going to give you a parent, and you have to get the new guy. And there's a couple of ways of going about doing this. I'm going to show you the foolproof, everybody gets the right answer way. If you can do it without showing me this, by all means, do it. Alright, so f of x, we know because its absolute value has a point at -1, 1, 0, 0, and 1, 1. So for g of x, I have no idea what I just wrote. We're going to do up 3. So we're going to take these points and everybody's going to move up 3, which means the y's are going to have 3 added to them. So these points become -1, 4, 0, 3, and 1, 4. So all you have to put on your graph are the new points and draw that graph. Now, again, if you don't need to do this to get the right picture, that is fine. I just need the right picture. But I prefer that you do it without relying on graphing it in your calculator. Alright, so now we have the square root of x. So f of x looks like this, which means we know we go through 0, 0, we know we go through 1, 1. We could do more points, but this is enough. So g of x, we have x minus 5, and the minus 5 is on the inside, so it's going to do the opposite to the x's. So we're going to take our x's and add 5 to them. So we have a point at 5, 0, and we have a point at 6, 1. And we know what the square root function looks like. Alright, so now we have f of x is x to the third, and he has points at -1, -1, 0, 0, and 1, 1. When it comes time for you to take your test over chapter 2, knowing what your parent functions look like is important. Because if you just rely on your graph, what tends to happen to people on your graphing calculator, what tends to happen to people is they don't give me specific points when they sketch the graph, and I take off points. So make sure you know cubic functions have these points. Know which points we put when we put our parent functions down, and how to translate them so you can give me accurate, specific points. Okay, so there's a negative on the outside. That's going to change the sign of the y's. So we're going to take all of our y's and multiply by -1. So that gives us a point here, a point here, and a point here. And remember that this function looks like this. So this is going to be a reflection of that. All right, so here we have f of x is the square root of x. So the points are 0, 0, 1, 1. G of x, we are doing the opposite of the x's. So multiply your x's by -1. And so we have a point here, we have a point here. We know square root looks like this. So if we want to reflect that over the y-axis, it would look like that. All right, so for x squared, we know -1, 1, 0, 0, and 1, 1 are points. We are trying to figure out what 3x squared looks like. You have times 3 on the outside, so you're going to times the y's by 3. And so you just get a tall, skinny parabola. Pretend like I went through those dots. Alright, so let's do one with multiple changes. So let's say that I'm going to change these. So let's say that f of x is, we'll do the cube root of x. And g of x is 2 cube root of x minus 1 plus 2. Well, let's make that a different number, because I want all the numbers to be different. We'll say plus 3. All right, so for cube root of x, we have -1, 0, 0, and 1, 1. And we know he's the one that looks something like that. All right, so to get our new points, we are, to the x's, the only thing that's happening on the inside is a plus 1. The y's, we have two things going on outside. We're going to times 2 and add 3. Order of operations applies. So we are going to times 2. There we go. All right, times 2, add 3. All right, so remember, inside opposite to the x's, outside same to the y's. So inside, all we have is that -1. So we do the opposite, we add 1 to the x's. Outside, we have a times 2 and a plus 3. Follow the order of operations when there's more than 1. So -1 plus 1 is 0. -1 times 2 is -2. Plus 3 is 1. All right, 0 plus 1 is 1. 0 times 2 is 0, plus 3 is 3. 1 plus 1 is 2. 1 times 2 is 2, plus 3 is 5. So we have a point at 0, 1. We have a point at 1, 3. We have a point at 2, 5. And we are trying to make the same picture. And remember that that 0, 0 point was the guy in the middle. So from him, you're going to go up and flatten and down and flatten to get that cube root look. All right. This is your assignment. Remember, take a picture and email it to me. If you have any questions about anything, email those as well.